Hi everybody, I'm Daudu and I'm presenting this time Factorial Experiments in Fractional Replication and R. Happy listening. This is the 7th in the series of my videos on design of experiment. Factorial experiment in fractional replication and R is the topic of the present presentation. And I'm claiming that irrespective of your version of R, reusable codes that I will present will run. I have assumed that you are aware of factorial experiment in fractional replication, so that my task boils down to giving you R reusable codes that will automate the statistical analysis. The reference material still remains Cochrane and Cox. Thank you. Now, factorial experiment in fractional replication. Sometimes the researcher or investigator is not all that capable, or the requirements for the experiment at hand may be expensive, far too expensive that it can bear. And then replications will be quite impossible. So, well, one is not sure, even if he needs that much to get the information he is looking for. So sometimes it is imperative to have a single replication. Have a single replication or quarter it, or even do an eighth of it. So fractional replication is about using half, a quarter, or an eighth of a single replication to analyze, working with those ones to get information that is required in the experiment. Now, in a single replication of a 2 to the power 6 factorial, each main effect is an average over 32 combinations of the other factors, and hence a 32-fold replication. Perhaps 4 or 8-fold replication will survive. Sometimes they do. In a situation like this, an experiment which consists of only part of a complete replication is worth considering. Now, a whole lecture on the topic ought to take us through defining contrast. I mentioned it briefly in a past video, immediate past video, that is, aliasing, halving, etc. Well, with respect to the data was obtained on an experiment which was a half replicate of a 2 to the power 6 factorial. The factors are A, B, C, D, and E. There are different constituents that go into the commercial manufacturing of icing for cakes. But there's an additional factor, which ought to be the 6th anyway, which the housewife may choose either to use or not to use. That means it's optional. An example of such a factor is the coloring that you mix up with the icing before you spray it on the cake. The defining contrast as such is A, B, C, D, E, F. 6 alphabet. So it's customary to use capital letter to denote factors. And the half replicate used is the texture of the icing. Well, that is contained in the table of the data. All right, the data. This is statistical analysis of half replicate of a 2 to the power 6 factorial. Now, the method that is being used here is Yates. You remember I gave it, there was a video on Yates. So if you've not seen that, please go look for that video. All right. Now, these are the 32 main effects and interactions. Since we are halving, we will take our addition and subtraction to the fifth. 2 raised to the power 5 is 32. And mind it, like I said, as a check, the value here must be equal to the value there. All right. I mean, you pair up, you sum. This plus this will give you 450. Then 267 plus 317 will give you 584. By the time you are through with addition, you have to do subtraction. I mean, 217 minus 233 will give you minus 16. Okay? 317 minus 267 will give you 50. And that completes that. When you are through with this, you go to the second column, the next column. And you continue like that until you go as far as the fifth column. By the time if you do your addition and subtraction very well, you see that the value here will be equal to the value here. That's a check on it. Now, something is of note here. We're assuming that 3 level interactions go to error. Okay? All 3 level interactions. See? They are labeled with error. As for 4 level interaction, their alias will be a 2 level interaction. Such is the case here. A, B, C, its alias is DF. You see, all 4 level interactions, the alias will be there. And that's it. Even a 5 level interaction has its alias as F, as you can see. Okay. Now, armed with the data, you feed R from here down the line there to here. Now, this will have been used to by now. And this is the texture. If you go back, 233, 217, 267. 233, 217, 267. Down the line like that. The data frame is given the syntax. Now, something that will take care of the 2 level interactions and ensure and tell her that 3 level interactions should go to error, and the like is this. In the model, see, the main effects, then 2 level interactions. Obviously, you have to do 6 takes 2, 6 combination 2 to know the number of 2 level interactions that are in there. And those are the ones that you are going to field. You are going to supply to her here. Otherwise, it will do something else. Then the data frame that you've called icing, the data here. If you come this far, you will have fed her with the data. All that remains is for you, and you will have even told her to even construct the analysis of variance. Coming this far, you fed her with the data, and this is for the construction of the analysis of variance. That's where you need the model anyway. After which, you now invoke it to give you the summary. The output will be more than this, but I want our discussion to be thorough on this. That's why I'm highlighting it. Okay, we'll notice that statistical significance are on F. See, 1%. And then on the interaction. Okay. Recall that all 3 level interactions are being kept in the residual, and higher level interactions would, like 4 level interactions, will have alias 2, and all the 2 level interactions are there. Now, 5 level interaction will have alias that are the mean effect. Okay. Now, so they are all that we require here, and these are their degrees of freedom, sum of squares, and so the mean of squares. It won't be different because the degrees of freedom are just 1 or through. It's the residual that's actually changing. And mind it, the residual is loaded because all 3 level interactions are supposed to inflate it. So this is the pertinent analysis of variance. And I'm sure if you follow the explanation, you will be able to reuse this code for your particular analysis. Well, this is the farthest I intend to go on factorial experiment in fractional replication and R. Watch out for the computation of another design or technique next time. Please like, share, and subscribe. Thanks for listening, and bye for now. Bye.